you have f plus g of x. Okay, that's how we say it, f plus g of x. Basically what that's saying is you take the function of x and you add to it the function of x, and then f of x, the function f of x plus the function g of x. Okay, so it's two different functions, two different equations, if you will, but not an equation, expressions. Okay, and we're going to add them together. This will make a lot more sense when I show you with actual numbers, but just so you can refer back, this is what it looks like. If I tell you to do this, you're actually going to do this. Okay. Subtraction, remember, addition is commutative. If we add them in the wrong order, it's actually going to be okay because it's not going to change your answer. If you do the subtraction in the wrong order, it's not okay. Subtraction's not commutative. You cannot flip them. So f minus g of x has to be the f of x function minus the g of x function. Okay. With multiplication, f times g of x is the f of x function times the g of x function. And then division, if I say f divided by g of x, it's your f of x divided by your g of x, okay? Why can't g of x be 0? Go for it.
Because you can't divide by 0.
Can't divide by 0. Okay, so that's the only one that has restrictions when there's division involved. And you'll see as we go where that kind of comes into play a little bit. Okay, so let me show you how this works. They're going to say, here are two functions. F of x is x squared minus 1. G of x is x plus 1. What they want us to do is they want us to add those two functions. So f plus g of x. All that means is you take f of x, and we're going to put them in parentheses. Not that it matters with addition, but it does matter with other ones. So just get in the habit of putting them in parentheses for this type of stuff. X squared minus 1 plus, right, we're adding the other function to it. The other function was x plus 1. Okay? That you should know how to do. We're not multiplying, right? We're adding them together. Make sure you pay attention to the fact that the symbol in between, the operation, is addition. So when we add this, you're just going to simplify. X squared, there's no other x squared, so it's going to be by itself, x squared. What's going to come next if we're going in standard form here? Plus x. Yep, we have this x, so x squared plus x, and then what? What are you left with? Negative 1 plus 1. What is that? 0, right? You don't need to write plus 0 because plus 0 doesn't change anything. So your answer is just this. We just added those two functions together. Okay, so take the functions for what they are, add them, you're good to go. Okay, using those same two functions up here, I'm going to just take a quick snapshot here of them and move it down here. Using those same two functions, now we're going to do f minus g of x. Okay, so that means we take f of x, which is x squared minus 1. Don't forget your parentheses because it matters on this one. Minus, right, that's this minus goes here. And we're subtracting x plus 1. We're subtracting the g of x function. All right, so now if we simplify this, there's still just the x squared, right? Then what? Plus or minus? Minus
X.
what? Minus x, yes. So this minus has to go to both of these things here, right? So this is x squared minus x. Then what? Minus 2, right? So this is a -1 and a -1, right? So -1 minus a +1, if you want to think of it that way, is -2, and you're done.
Would it be wrong if you just put it as like x minus 2? Like, you subtracted the x from the x, or no, because it's
If you subtracted these,
yeah.
yeah, no. Remember, your exponents have to be the same for you to be able to subtract them. So x squared minus x squared would go away, right? But if you just do x squared minus x, you can't combine that. Yeah, different exponents. Good question. Okay, letter C. And I'm going to screenshot here my two functions again and bring them down. Oops, I keep forgetting to re-click. Okay, now this one says we're doing what to the two functions? We're multiplying, right? This is multiplication. When it's just f next to g like that, we're multiplying. So this one, we're saying x squared minus 1 times x plus 1. What do you do with that? Distribute. You FOIL it, right? This is FOIL. So we're going to go x squared times x is what? X cubed, right? X squared times x to the first is x to the third, plus x squared, that's your outside, minus 1x, or just x is fine, is your inside, and then your last is going to be minus 1. So you get x cubed plus x squared minus x minus 1. Okay? Questions on that? Okay, here's where it gets a little bit trickier. We're dividing, and it's really tempting on this one to divide improperly. So let's take a look at this. We're taking the f of x function, x squared minus 1, and we're dividing by the g of x, x plus 1. Now, what most people want to try to do right here is like, oh, there's ones, let's just get rid of those ones. And there's an x and an x, let's just get rid of an x. Because this is an expression and this is an expression, we have to do that addition and subtraction before we can do any division, right? And because we can't, because one's a variable, then you can't just start, people always say canceling out. It's not canceling technically. It's making it a 1 or making it a 0. So instead, what we need to do is see if there's some way we can simplify this. Does anyone see something we can do to simplify our numerator? What's x squared minus 1 in a different form?
Can't you turn it into x, and because 1 is also you can do divided by
Oh, they're perfect squares.
Yeah.
Is that what you're saying? The perfect squares definitely comes into play, but you can't just turn it into x. But yes, you're in the right mode here. This is called a difference of squares. Do you remember what we did with difference of squares? We factored it some way. Do you remember how this factors? You could always do star method if you don't remember how it factors. But difference of squares was where we square rooted both, and one becomes x plus 1, and the other becomes x minus 1. Remember that? Yeah? Draw from that first semester memory of yours. And that's over x plus 1. Now do you see what you can do with that? What do you think you can do? What would you do? Can you divide anything right now? You can divide x plus 1 by x plus 1, right? Anything over itself is what? 1. So it's okay for you to do this. You just can't do like just the x's, right? You can't do that. But this is some number, x plus 1, divided by some number that's the same number, x plus 1. So that's 1, okay? That goes away. That means this whole thing equals x minus 1. Okay, so just keep an eye out. When you see a difference of squares, that should factor to 1 plus and 1 minus of those perfect squares. Okay, just make sure you don't start just canceling out x's and canceling out 1s. We don't want to do that. Okay, take a look at this next one. So now we got 2 new functions. F of x is 2x plus 1, g of x is x plus 5, and we're going to divide them. Okay, so this is going to be 2x plus 1 on top, x plus 5 on bottom. Is there anything you can do to factor? Is there anything that we can perfectly divide out? The answer is no, there isn't. There's nothing else you can do to simplify this setup. It's tempting to say, sure, we can get rid of an x and call this just x, and then this x goes away. Remember, when it's an expression like that, you have to get rid of the whole expression with the whole expression together, okay? We can't on this one, so it looks like this. Now, there's one other thing we have to say still, though. Remember what we said with division? There's restrictions. So what can x not equal right now? -5, right? This cannot be a -5 because then this whole thing would equal 0, and you can't divide by 0. So you just need to make sure that you state the restriction, x does not equal -5, and that will be your answer. Okay, so it's the one over the other, 2x plus 1 over x plus 5, but x cannot be a -5. Good on that? Okay. Then a composition of functions. So this is going to take multiple functions and do things to them together. This is where it can get a little bit tricky, just based on what order you do it in, and if there's just a variable instead of a number, it can be a little bit trickier, so stick with me here. Basically, we're saying f of g of x, right? F of g of x. It's the same as this, f of g of x. Basically, what we're doing is when you see this, you're going to evaluate from the inside out, okay? So we're going to evaluate this first, and then we're going to plug that value into the f function. So we're going to start with the inside function, the g of x, and then plug that answer into the f of x, okay? Yeah, if you want to make a little note, we're going to start inside and work your way out when you do these. So if you look at this first one, f of x is x minus 2, g of x is x squared. And what they're saying is evaluate f of g of 3. Okay, so here's what you do. You start here. Okay, forget that there's even an f involved right now, and I just want you to evaluate g of 3. Okay? G of 3 is what? 9, right. You take that x value and you plug it in, right? So g of 3 is 3 squared, or 9. Okay, so now here's what this is saying. Now take f of that. So now they're saying take f of 9, right? Whatever you got for your g of x function, now plug that into your f of x function. So that f of 9, that's going to go up here. F of 9 equals 9 minus 2. So I'm just plugging it into this f of x function. 9 minus 2 is 7. So that means f of g of 3 is 7. Okay, so it's kind of like you're solving two problems. You're solving the inside one first, and then moving to that first, the beginning, the outside version of it. You kind of think of it like laundry, right? So you put it in the wash machine, and it does its thing, but that comes out wet. We still need to dry it, so put it in the other machine, do its thing. You know the function machines? Do you remember function machines from like elementary school? I feel like they usually looked like... Where was the output? Was it down here?
Yeah.
Yeah? Right? It was like, what are you going to put into this function to get whatever you get out, right? The washer and the dryer are your two function machines. You put something into the wash machine, cleans it all up, but now it's wet. Put it into the dryer, dry it all up. Now you have this beautiful laundry, right? Okay, so let's take a look at g of f of 8. Okay, now notice our letters switched places, right? G of f of 8. What do we evaluate first? F of 8. Okay, so you're going to take f of 8. So go up to your f of x function up here. That's 8 minus 2. So f of 8 is 6. Now what do you do? Now it's g of, right? Now we do this part of it. So it's going to be g of what number? G of 6. Yep. G of 6 is 6 squared. We're just plugging it into this function, which is 36. So g of f of 8 is 36.
You have to rewrite
You good?
yeah.
Okay. Okay, you try letter C. F of g of negative 4. See what you get. I'm gonna copy these down over here. Are you starting with G or F? G. What'd you get?
14.
Yes. So G of negative 4 is where we're going to start, right? So that's going to be, parentheses matter, negative 4 squared. So G of negative 4 is 16. Then we're going to plug that into the f of x function. So f of 16, okay, when you plug that in, it's into this function. 16 minus 2 is 14. So f of g of negative 4 is 14. You do not need to box up both of your answers for me. I just need the final answer, but I do want to see the work that went into finding that final answer. Okay, so show me what you're doing on those. Okay, letter D. This one's a little different. G of 3. What's the issue? It's not an issue. What's different? It's do the same function twice, right? It's G of 3. So you start with G of 3, and G of 3 is 3 squared, or 9. So now you take G of what? G of 9, and that's 9 squared, or 81. So you get 81 for your answer. Okay. Any questions on that? Okay. now we get a little fancy with our variables. So you have two new functions here. F of x is x plus 3. G of x is 2x. But now notice how this looks. F of g of x. Okay, so what they're saying is we're going to plug x in for x. Sounds strange, right? It is strange. So here's the deal. If we start with this, okay, basically they're saying you get this. G of x is 2x. Okay, that means now we're going to take that 2x and we're going to drop it in place of x on our f of x function. Okay, so now we're going to take this and we're going to bring it in right here. So x is going to be replaced with 2x. So we would say f of g of x is 2x plus 3. Does that make sense? So we plugged an x in for our initial function, or for our initial function here, right? 2x is just, that's what we get. G of x is 2x. And we plug that g of x function into our f of x function at x. Okay? Now flip it. Now they say take the f of x function, x plus 3, and we're going to drop that into our g of x function for x. So now I'm taking x plus 3. Let me erase some of this chaos. Okay, now I'm taking this and I'm dropping it in for x. What do we have to do with that? 2 times, make sure you do parentheses, right? We want to distribute. So it's 2 times that x plus 3 function. So that's going to be 2x plus 6. So g of f of x is 2x plus 6. That makes sense? Okay. All right, last 2 here, and then we're done. 2 new functions. F of x is x squared plus 1. G of x is x plus 3. Okay? This notation is no different than what you were seeing up here. Okay? It's still in the order that we're used to up here. You still take the inside one first and then the outside, right? So for example 5 here, we're going to start with the g of x. So if you like to think of it this way better, I like this way better personally. It's the same thing, okay? F of g of x is f of g of x. So you're going to start with g of x, x plus 3, okay? And you're going to plug that into the x in the f of x function. So think about what that looks like now. You have x plus 3 squared plus 1. How do you square x plus 3? Foil it, yes. So if we FOIL x plus 3, and if you know the little shortcut for foiling a binomial like that, or for squaring a binomial like that, you're welcome to use it. It's basically square the first, square the last, and then 2ab. Remember the a squared plus 2ab plus b squared? Do you remember that? We didn't spend a lot of time on it. So this is x squared plus 3x would be plus 6x plus 9. Okay, so that's x plus 3 squared, but then don't forget we have this plus 1 at the end. So it's x squared plus 6x plus 10. Okay? Questions on that? Okay, you see if you can do b then. This one flips it, right? It's the same 2 functions, but we're going to start with f of x, and we're going to drop that f of x into the g of x function. See what you do with that. I think this one's quite a bit simpler. So if you're like, that was too easy, it's okay. It probably should be a little too easy. Everyone got it? Someone's got it. Be bold. Remember, I love mistakes. I mean, I love right answers too, but it's okay to be wrong. Go for
X
it.
squared plus 4.
Yeah. So f of x right now is this, right? We're plugging that in for the x in g of x. So it's x squared plus 1 plus 3. Now, technically, you could put parentheses around that. It doesn't change anything, so you don't need the parentheses on that one. But what you can do is simplify these, x squared plus 4, and that is your answer. A little nicer than having to FOIL up here, huh? Any questions on that? Okay, so just remember, start with the one that's inside right by the x and work your way out from there.
While x squared plus 1 is still in parentheses, you can still add 1 plus 3. Like you don't have to.
Yeah.
Yeah.
Yeah, because, yeah, the parentheses are not changing. There's no like value change if we take those parentheses away versus if we have those parentheses there. Basically what we're saying is we're just gonna apply the associative property. Remember, associative property says if you move the parentheses around a different set of numbers, when it's just addition like that, you can add the other numbers first. So, yeah. Anything else?